Would you like to learn about BGP? If so, this video is for you. Hi, my name is Michael Gibbs and I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building high-performance cloud computing careers. I've been working in technology for 25 years, and I've been coaching, teaching, and mentoring others for well over 2 decades. And today we're going to talk about one of my favorite topics, BGP. So I started my career as a network engineer, and I have 25 years experience in networking, and I love BGP. I've used it everywhere. In fact, I spent over 10,000 hours working on BGP. So it's near and dear to my heart. So the topic of today's conversation is going to be BGP, which is one of those critical skills for cloud architects. And BGP should be part of the network training for everyone working in the cloud computing community because it's the primary routing protocol used in the cloud. So what we'll talk about today is what is BGP, then we'll talk about why we use BGP, and then we're going to talk about how BGP works. Now this is part of a 2-video series. Today we're going to talk about what it is and how it works, and the next video that we're going to do next week is going to talk about how to tune BGP for traffic engineering, and that's where the fun begins. But we've got to get through this to be able to understand that. So what is BGP? BGP is a routing protocol. See, routers are these network devices, and they have lots of interfaces. We'll pretend my arms are interfaces. They have interfaces going in all different directions. And what happens is the router is basically a computer with a bunch of network cards in it. And the router builds a map to say, to get to this destination, use this interface. To get to this destination, use this interface. To get here, go down there. And that's what the router does. It directs your traffic through the internet. It makes your traffic go from point A to point B. Routers are critical. Now, routers need to know how to get your traffic from point A to point B. So imagine this. In the old days, let's pretend you had a map that only had one path to the destination, and you just took it. That would be what we would call a static route. A static route is where you manually tell the router how to get to this location. Now, there's a problem with that. If I only know one way to go somewhere and the road is blocked, I can't get there. So that's no good. So static routing is related to manually telling a router to reach point 1 to point B. Now let's say I'm going to my friend's house for dinner. We're going to now basically talk about a dynamic routing protocol. And let's say I've got a GPS in my car. And I get in my car and I try to drive to my friend's house, but the road's blocked and my GPS says rerouting. And it takes me to take a side road. And then it tells me to take another side road, and it reroutes around the traffic, and I get to my destination. That's what routers do. So when we talk about routing protocols, they're basically a way for routers to dynamically learn how to get to every destination and build a map of the network. So a routing protocol is like your GPS, and it is basically a dynamic way for routers to learn what we call network layer reachability information, or networks and subnet. So that's what we use routers for. So these routing protocols help the routers build a map of the network in a dynamic manner, and they can reroute. So if you had a static route from one location to another and the location went down, you're stuck. By adding a dynamic routing protocol, you improve availability and performance of your systems. Now, there are 2 kinds of routing protocols. There are interior gateway routing protocols and there are exterior gateway routing protocols. Interior gateway routing protocols are used inside of an organization. Say, Go Cloud Architects. I have OSPF running on my internal network. That's my interior gateway protocol. Let's say I want to connect to AWS. We're talking about AWS BGP, so let's talk about connecting to AWS. So they have an interior gateway protocol running in their networks too. It's going to be OSPF, or intermediate systems to intermediate systems, and they probably turned on label switching or some tag switching, some form of MPLS. And they probably turned on some RSVP signaling, and they're also running something called IBGP, but that's neither here nor there. But they're going to connect to external organizations using BGP, because BGP is an exterior gateway protocol. So organizations, when they connect to other organizations, use BGP because BGP is designed to connect external organizations. So let's talk a little bit about BGP protocol. At the basic level, understand that it uses TCP port 179. So a TCP connection is established, which means it's unicast. Almost every other routing protocol is multicast. A router sends a hello to every other router. They establish an adjacency on their own, but not BGP. BGP is unicast. In fact, you need to tell BGP who you want it to connect to, unlike the other routing protocols. So you do that. So BGP is unicast TCP port 179. Why am I highlighting TCP port 179? Because if you've got a firewall and BGP is traversing through that firewall, and you don't allow TCP port 179, your BGP session will never be established, and if it is, it'll get torn down pretty darn quick. So you might need to know TCP port 179, and if you're studying for like the AWS Advanced Networking, you may see that as an exam question, or any of the AWS certifications. BGP is used for the following reasons, and this is why organizations use exterior gateway protocols. They scale. They are really scalable. For example, when I connect to the internet with a big internet-facing router, and let's say I connect to 10 different internet service providers, which is the kind of thing I've did my whole life. If each internet service provider is giving me 750,000 routes, that router in its routing information base is going to hold 7.5 million routes. Think about that. That's how scalable this protocol is, to hold that much. So that's why organizations use this. And pretend you're AWS or BGP, or using AWS BGP or Google using BGP, and you've got hundreds of thousands of clients. You need something that's going to scale like that. So understand that's why these organizations use BGP. In order to understand BGP, we have to talk about some messages between them. In order to understand BGP, traffic engineer, and do all the cool things we need to do, we need to do this. Now we're going to get a little bit in the network engineering weeds here because we have to. My apologies. I love to talk about leadership things, but we got to be deep tech here, so we're going to do it. I'm going to put on my tech hat, and we're going to be using it for the day. So let's talk about the messages that are exchanged between BGP peers. So BGP peers exchange messages, and that's how they know to update the map, like your GPS. There's going to be 4 messages we're going to talk about. We're going to talk about the open message, the keep alive message, the update message, and the notification. Open message. So realistically speaking, BGP router 1, BGP router 2, they establish a TCP connection and they send an open message. And what's in this open message is negotiation of a version number, say BGP version 4 versus version 3. They talk about the autonomous system number, and every organization using BGP has to have their own autonomous system number that identifies the organization. So I would have one, and AWS would have another, and I would give them my autonomous system when I connect to them, and they would give me their autonomous system when I connect to them. It's part of the neighbor relationship. Something called a hold time, which is how long these routers will wait before they receive a keep alive to determine if things are good or bad. And then something called the BGP identifier, which is just the IP address of the neighbor. Now we're going to talk about keep alives. And a keep alive is a message that's sent in between 2 BGP neighbors. It's a health check. It keeps the TCP connection open. So let's take it out of BGP to take it to a place that most of the cloud architects are more familiar with, things like load balancers. A load balancer basically takes things in and it splits the load among multiple servers. And the load balancer says to the servers, are you there? Are you there? Are you there? And the servers say, I'm here, I'm here, I'm here. And as long as the servers respond, I'm here, they stay and they're used. But if the load balancer reaches out to a server, are you there? Are you there? Are you there? And nobody responds, the load balancer instance or that load balancer determines it's not there, it gets marked as unhealthy and gets removed from the rotation. BGP does the same thing, and it's done it for the last 30 years. That's what this whole point of the keep alive is. Are you there? And after a number of keep alives are missed, the router gets removed from the neighbor adjacency, the session is torn down, and all the routes learned are gone because they assume if you don't respond, that neighbor's dead. And that's why it works just like a health check. So now let's talk about the next kind of message, which is called an update message. So you've got a TCP neighbor established, and you learn a new route, you got to tell your neighbor. And that's what the update message is. Basically saying, I've learned a new route, or I've learned a route went away. That's the update session. So it basically gives you the prefix or the subnet of that you're trying to reach, or your aggregate route, whatever it is trying to reach, and it gives you your path attributes, things like your next hop, your origin, your AS path. So that's realistically what's in an update message. The last message we're going to talk about, and then thankfully we'll be done the message, is something called a notification message. Basically, if something goes wrong, you get a notification message. So what are these messages one more time? TCP session is established as an open message sent between them. Basically negotiate your parameters. Then a keep alive is a health check. Just think of it that way. Are you there? Are you there? Are you there? After that, we'll talk about the update message. It's like, I got a new route and here's how I learned it. Or I've got a new route, or I lost a route because the neighbor went down. All those things are part of it. And a notification is, hey, something's wrong. This is not a good thing. The BGP session will be closed. Now the next part of our deep technical discussion on BGP is how BGP forms a neighbor relationship. Now I know this is deep, but this is very important cloud network training. And let's face it, if you want to work in networking and cloud computing, you just need to know BGP. So bear with me. I'm sorry, it's a little deep and technical. We'll have more fun in the next video. So when BGP forms a neighbor relationship, we've got a couple of states. We've got an idle state, a connect state, an active state, an open sent state, an open confirmed state, and an established state. I'm going to try and get through these things as quickly and simply as possible. But the reason we're doing this is when you establish a BGP neighbor relationship, and sometimes things don't work, you got to troubleshoot it. And these are the states that you're going to be looking at, part of what's called the finite state machine, how BGP works. And if you know this, you'll be able to fix it. And if you don't, you won't be able to troubleshoot it. So idle. When a BGP router comes online, it's idle. Basically meaning it's waiting for a TCP session to come up. And if anything were to go wrong, it'll revert back to the state idle. So if it's been up for a while and now it's idle, something went wrong. After it goes from idle, it goes to connect. And realistically speaking, this is where the TCP connection is forming and an open message gets sent to the neighbor. Now, if all goes right, this is great. What happens is it transitions to open state and the next phase is go. This is what's supposed to happen. Now, if anything were to go wrong when you're trying to establish this connection, it's going to transition to something called active. And when it's an active, it's going to go try and retry the connection. And if it doesn't make it, it's going to go back to idle. So connect is either going to go well and transition to open. It's going to go to open sent, or it's not going to go well and it's going to transition to idle. So idle is where you begin. Connect is where you go. Hopefully, things go well. If they don't go well, you're going to be in this active state, which is, as I mentioned before, which is where the router is going to keep retrying the TCP connection. And if it doesn't work, it's going to go back to idle and that's it. So if everything worked, the router transitions into open sent, which basically says the open message has been sent and it's waiting to hear an open message from its neighbor, and that's it. And during this time, if everything goes well, then things are going good and a keep alive message is sent. Now, if things don't go well, we've got a problem, but let's assume they do. Now we're going to enter the state of open confirm. And this is basically speaking where you've received your message and you're sending your keep alive. Of course, if anything goes wrong, it's going to transition back to the idle. Now we've reached the good part, established. When you're established, you know your BGP neighbor relationship is good, messages are going to be exchanged, and this is good. This is party time. If this occurs, everything is good. Now, if the TCP session gets torn down, it's going to transition back to idle. So now you know basically the BGP message types, and we talked about the BGP finite state machine. We've done some network skills training. Now we have to talk about some BGP attributes. And the reason we're going to talk about BGP attributes in this video is next week we're going to teach you how to tune and traffic engineer BGP, which is where the fun begins. But what's going to happen when we tune BGP is we're going to be playing with the attributes. You got to know what they are. So the BGP message that you receive, so the router gets these messages and it's going to say, okay, here's my next hop IP address. For example, here's the number of AS paths that it went through. This is the weight, this is the local preference, and these are the kind of things that you're going to learn. And these are the things that you kind of tune. So let's talk about what these are. The attributes are basically things or characteristics about a route. So one of the characteristics is going to be the origin. Where'd you learn the route from? Now, if you learned it from your neighbor via eBGP, that's one type. If you learn it from your IGP, that's another type. And if you learn it via another way, that's a third. So basically what happens is BGP is going to prioritize with the origin based upon what it sees. So if in your routing table you learned it via your IGP, say OSPF, that's going to be preferred. Now, if you learned it via BGP, it's going to be second preferred because OSPF is deemed more reliable in certain cases than BGP. Now, if you learned the route via something incomplete, like maybe somebody redistributed a connected or static route somewhere and you're not sure, or it doesn't have incomplete information, that's going to be called incomplete. And this is the last choice. So routers will prefer the routes learned by the IGP, like OSPF, or and then the EGP next, and then incomplete route. Now, when we're looking at BGP, it's a path vector routing protocol. So it's going to tell you. So let's say it traversed AS 64501, 64502, and 65503 before getting to me, 65534. I don't know. I'm making up AS numbers that are in my head as we're going through. So I will see which AS is the route twin. So that's going to tell me how many AS hops. Generally speaking, routers prefer the path with the least number of autonomous system hops because it feels closer. So understand that AS path refers to how you learned the route. Which autonomous systems did it come from? Shorter AS path is preferred as a rule. The next thing that we'll talk about, one of these critical BGP attributes, is something called the next hop attribute. That's where you send your traffic. Okay, to reach this next thing, go to router 10.1.2.3. That's my next hop IP address, my neighbor adjacency, or what have you. So this is critically important, because if the next hop is not reachable, even if you learn the route via BGP, it won't be placed in your routing table, which means you won't be able to reach it. So super important that the next hop is reachable. And when you're troubleshooting BGP and you see it, but it's not in your routing table, chances are your next hop is not reachable. Happens all the time. Another attribute we'll talk about is wait. Wait was a Cisco proprietary means to influence your outbound traffic for forever, but it's now supported by AWS and some other people as well. So wait is another attribute to manipulate your traffic. Okay, so we've talked about a lot of things today. We talked about BGP messages, we talked about the finite state machine, and we talked about attributes. So the last thing we're going to talk about today is, how does BGP select a path? Ding, 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 ding. This is really important stuff, because all BGP traffic engineering, or all BGP policies, are going to be set based upon this path selection process. So while I have my engineer hat on, and I've got my little propellers on my hat today, and I'm having fun with the tech, understand we have to cover this. So BGP path selection process is as follows. Prefer the path with the largest weight, easiest thing to manipulate. If the weights are equal, prefer the route with the highest local preference. That's the next thing in the algorithm. Now, if the local preferences are the same, prefer the route that was originated locally on the router. And if that's not the case, if the local preferences are the same, for example, now prefer the route with the shortest AS path. And if the AS path is the same, now you're going to prefer the paths with the lowest origin code. This is where we talked about an IGP being better than AGP versus better than incomplete. Now, if the origin codes are the same, then you're going to prefer the route with the largest MED, or multi-exit discriminator. And if the MEDs are the same, then you're going to prefer an eBGP route versus an iBGP route. Now, at this point, we're getting far in the process, and BGPs just has to find some way to win an election, or choose a preferred path. So we're going to get into some funny factors now. So if the routes are still equal, prefer the route with the shortest path to the BGP next hop. And this is going to be determined by the lowest IGP metric, meaning how far it is to get to the next hop IP address. And if the routes are still equal, prefer the router that told you first. So if my friend Jeff told me before my friend Joe, I'm going to take the one that Jeff told me first. Kind of improves stability, and that keeps things from flopping up and down. And then now we're getting into funny business. If all the routes are still equal, prefer the route advertised that you learned from the router with the lowest IP address. So we covered a lot of tech stuff today. And all of this is networking for cloud computing, and whether it's AWS BGP or GCP BGP, this is critical cloud architect skills. And I view network skills training for the cloud architect to be some of the most important things to know. Why? The cloud is a virtualized network in a data center, so you must know networking. And if you want to be a cloud infrastructure architect, this becomes incredibly important. But what did we talk about today? We talked about what is BGP. We talked about why you use BGP, and then we talked a lot about how BGP works. Next week, we're going to have a party, and we're going to talk about BGP traffic engineering. It'll be much more fun, but we need these fundamentals to get there. If I could please tell you about some free services we do for the cloud computing community to help you. On Mondays and Thursdays, we have a completely free How to Get Your First Cloud Architect Job webinar. On these webinars, we will tell you everything you need to do to go from AWS certified to completely hired. And if you're new and you're not certified, we will tell you the whole process to get hired. We do this every Monday and every Thursday. We present for an hour, and then we let you ask us any kind of questions you want for an hour, and we will give you real-time advice and guidance to the best of our abilities on these live calls. And we do everything we can to help you in your cloud computing career. Now, every Tuesday, we have a really fun Cloud Architect Experience webinar. On these webinars, we give you a complicated situation from a data center, and we talk about migrating into the cloud, and in real time, we design a cloud architecture with our guidance, of course, and we do that completely free every Tuesday. Now, most Wednesdays, we try and do a free live stream on YouTube where you can bring us any cloud architect career questions you may have, and we will answer them for you in real time. We don't do them every Wednesday, but when we ever have time, we do. So please subscribe and hit the bell to be informed of new videos. We do these as many Wednesdays as we can. Now, we have a lot of free materials to help you with your certifications. For one thing, we are doing an AWS Advanced Networking Bootcamp completely free on the week of July 13th. I'll leave the link in the description below. Please attend. We just did one for the Certified Solution Architect Professional. People had lots of fun. We have 20 minutes of lecture, 10 minutes of questions. We do this the entire time, and that way it's like a real classroom, and it's completely free. We also have to help you with your certification, a complete and total AWS Certified Solution Architect Associate course and an AWS Certified Solution Architect Associate ebook. Again, the link is in the description below. And we have a completely free AWS Certified Solution Architect Professional Training Program. The link is in the description below. Thank you so much for the opportunity to communicate with you via YouTube. It's a real pleasure and an honor to be part of the Cloud Architect community, and I don't take that lightly, and we do everything we can to help you all in your cloud computing careers. Thank you so much for watching this video, and I look forward to seeing you in the subsequent video of this, the sequel, next week.